So let's look at a slightly different database, which may be a little bit more interesting than courses and instructors, and also have a few variables to talk about rather than having a whole bunch of things that we need to quantify even though we don't need. Probably all of you have seen genealogical database at some point in time, a database that contains information about people, who is a parent of whom, who is married to whom, and so on and so forth. So for example, this picture is for the House of Stuarts, royal family, and this diagram shows who is married to whom and who is a parent of whom. So what kind of relations can we expect to have in this database? Probably the main one we could use here is a parent relation. So we could query the database with two names, call them X and Y placeholders, and it will say yes, true, if X is a parent of Y, so the person, first position in the parent is a father or mother of the person in the second position, and we will say false, no, otherwise. So for example, in this picture, you could see that there is a lot of parent relations and some other relations that are not parents. So for example, if somebody is grandparent, then they're not a parent. And also, we are not going to use them as much, but we could have a relation that female or not female, married, two names for the same person or not, and so on and so forth. Now, what can we do with this kind of genealogical database? We could ask more complicated questions than just parent. Some questions we will be able to ask. Some questions are actually pretty hard to do with logic. But let's try to do the one that we can. Here's one example. So we have a predicate, a query for a parent. But if you want to find out if somebody is grandparent of somebody. So let's write a formula that takes two variables, names of people X and Y, and returns true if X is a grandparent of Y, and returns false if X is not a grandparent of Y. So sometimes people get confused here because I'm using X and Y and a parent, and then I'm using X and Y and a grandparent. But I don't really mean that this is the same person X and the same person Y. I just mean that there are two placeholders, like the first entry and the second entry in the parent, and two placeholders in the formula for grandparent that we are going to write. And I'm just out of habit calling the first one the first place X and the second placeholder Y. And X and Y really don't need to be X and Y. We could call them anything as long as we don't use the same name. We could call them, granny and kid. That would be okay. They will be the free variables in our formula. As long as we can refer to them somehow, we are fine. So let's do the formula. So we have two variables X and Y, and we could use parent of whoever as many times as we like, and we want to write something that will be true when X is a grandparent of Y. So what does it mean to be a grandparent? Let's just think about it for a moment. So X is a grandparent of Y means that X has a child who is a parent of Y. So a son or a daughter of X is a father or mother of Y. So right away when you look at it, you say, well, this formula is talking about one more person. And this is that child of the grandparent and parent of the kid that we need to talk about. So we will need to use one more variable to talk about that person. Now, how are we going to quantify that variable? It's not given to us, so we have to use a quantifier. Well, not everybody would be the child of X and a parent of Y, even if X is a grandparent of Y. Well, if it's not everybody, it must be somebody. So there is somebody who is a child of X and a parent of Y. So for that somebody, the formula parent XZ and parent of ZY should be true. Whenever X is a grandparent of Y, such a Z would exist. So now, with this quantifier, the final formula becomes there exists Z, that is a parent of XZ, that X is a parent of Z, and Z is a parent of Y, which means that X is a grandparent of Y. It will be true exactly when such a Z exists. So let's look back at our kings and queens. So who is the grandparent of whom here? So for example, here the Henrietta Maria of France is the grandparent of Mary II. And the reason she is a grandparent, actually is she? Yeah, I think so, is because she is the mother of James II, who will be the witness for that variable Z in our formula. And try it for yourself. If you put in names of people who are indeed grandparents, you could always find the grandparent and grandchild. You could always find the witness for Z. But if you put in names of two people such that the first one is not a grandparent of the second, or even put them in the wrong order, you wouldn't be able to find such a Z. So for example, if you look at George the First, well, he doesn't even have children, let alone grandchildren. There is nobody that he is a parent of. So the first part would, of our formula, parent XZ, would already be false. So that's not a grandparent. Okay, so let's experiment with our formula a little bit more. What if instead of talking about any grandparent, we want to talk specifically about grandmother? Well, the only additional thing that we need is to say that the person who is grandparent is female. And if we have such a relation in our database, we can just say it. So somebody is a grandmother of X is a grandmother of Y if X is female and X is a grandparent of Y. And for the second part, we just reuse the same formula as we had before. Okay, so now that you're probably getting more comfortable with how things are working, with writing formulas about relations of people in geological database, let's try a little bit more complicated formula. So suppose we want to write a formula which would be true for a person X if and only if X is the only child of both parents. This time, in addition to using predicate XY, we will also need the predicate X equals to Y because we would need to say things like this child is different from that child, even if they have exactly the same parents. So what does it mean to be the only child? It means that anybody who is a parent of X has only X as a child and nobody else. Well, it's a little bit hard to say it like that, so why don't we write this formula in a little roundabout way? Let's start by writing its negation, and then we will get the formula for the single child by negating the result. Because to talk about the negation of being a single child is easy. All it's saying is there is another different child of the same parents. There exists a sibling. And here, for simplicity, a half-brother or half-sister are considered to be a sibling. So if this is child of only one parent, that's fine too. So we will use, again, predicate parent to say parent to define what it means to be a sibling. And we will use equality, or rather its negation, to say that this is a different child. So let's do it. So let's first write the formula for X is not the only child. That is, there is a sibling. So we need a variable for the sibling. And additionally, we will need a variable for the parent, because to say what it means to be a sibling, you need to talk about their common parent. So to write a formula that says that X has a sibling, we could say that there is parent, there is Y, who we are thinking of as a father or mother of both X and the sibling of X, and there exists Z, who is the sibling of X. So what it means that Y is a parent of X, and also Y is a parent of Z. And finally, what we need to say is that X and Z are different people, because who knows, that maybe two names of the same person. One trick with those databases is when you put in quantifier, there is nothing a priori preventing your variables from taking the same value. And X and Z can take the same value. If you want to disallow it, you need to write it explicitly as it's not true that X is not equal to Z. Okay, so now that we got the formula for X has a sibling, let's just negate it to say X doesn't have a sibling, so X is the only child. We put negation sign in front, and we simplify it as we did many times before. So our quantifiers flip. Exist Y, exist Z becomes for all Y, for all Z. Parent YX and parent YZ and not X equals Z becomes by De Morgan that either Y is not a parent of X, or Y is not a parent of Z, or X and Z ended up instantiating to the same value. So this one is a little bit awkward to read. It's a little bit easier to read if you turn this into an implication by taking not parent YX or not parent YZ, undoing the De Morgan that we just did to get not parent YX and parent YZ, and then getting rid of the negation and introducing implication to say if Y is a parent of X and Y is a parent of Z, the only way it can happen when X and Z refer to the same person.